Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Today we are going into chapter 8 of paper 3, complex number. So for this lesson, I will focus on the division of complex number. But before we can learn about division, we need to know about conjugate. So for the conjugate of the complex number, the definition is over here. If you have a complex number in this form, z equals to a plus bi, then the conjugate will be defined by z s3 equals to a minus bi. So the symbol here represents the conjugate. And what's the difference between the original complex number and the conjugate? The difference is at the imaginary part here. When the imaginary part 1 is positive, then the conjugate will be a negative. The real part remains the same. So for example, if my z is equals to 3 minus 4i, then my z conjugate will be equals to 3 plus 4i. That's the conjugate of a complex number. So what is so important about the conjugate of a complex number? Have a look at the properties here. So for a complex number in this form, z equals to a plus bi, if you plus the z and the z conjugate, you get a real number 2a. I'll explain it over here. Z conjugate is equals to a minus bi. So if I have z plus z conjugate, means it's equals to a plus bi plus the a minus bi. And hence, you will get the 2a over here. If z minus z conjugate in the second line here, you will get 2bi, because a plus bi minus a minus bi, then we will get 2bi, an imaginary number. But what is important here is when z multiplied with its conjugate, we will get a squared plus b squared, which is a real number. So I'll prove it here. When z multiplied with z conjugate means it's a plus bi multiplied with a minus bi. So we can just expand it as usual. We'll have a square plus abi minus abi and minus b square I square. So these two terms can be cancelled off. So you'll be left with a square, and the I square here is actually equals to negative 1. So eventually we'll get a positive b square, which gives you this. So notice that when the z multiplied with the z conjugate, we will get a real number. Alright, for now, let's see how we can apply the conjugate properties into the division of a complex number. Have a look at the question here. You are asked to simplify this fraction into a plus bi form, which is the standard form of a complex number. So for this fraction, the upper part is a complex number, and the bottom part is also a complex number. It's impossible to simplify into this form unless we change the bottom part into a real number. So to change the bottom part into a real number, we have to multiply with its conjugate. So what's the conjugate of 5 minus 2i? It's 5 plus 2i. So for the bottom part, I will just multiply with 5 plus 2i. So if the bottom part we have multiplied with 5 plus 2i, the upper part we have to do the same so that we don't change the question. So for now, you just need to simplify it. So for the upper part, we just do the multiplication as usual. 2 times 5 will get a 10. 2 times 2i will get a 4i. 9i times 5 is 45i. 9i times 2i is 18i squared. And for the bottom part, if you notice, is a minus b times a plus b. Still remember the one of the theory, a squared minus b squared is actually equals to a minus b and a plus b. So we can apply it here. So this is a, this is b. So eventually you will get a squared minus b squared, which is 5 squared minus 2i squared. So now let's simplify it. For the upper part, notice that the I squared is negative 1. Then we can group the real parts together, which is the 10 minus 18. We shall get negative 8. And for the imaginary part, it should be 4 plus 45, which is 49i. And for the bottom part, 5 squared is 25 minus 4i squared. And the I squared at the bottom, it's negative 1. So negative become positive, which means it's 25 plus 4. So it's 29 at the bottom. That's how we change it into a real number. So if we multiply 5 minus 2i with 5 plus 2i, the conjugate, then we'll get a real number here. So when we have changed it into a real number, the upper part is the same, then only we can split it into the a plus bi form, the real part and the imaginary part, which is negative 8 over 29, the real part, and the imaginary part is 49 over 29i. So this is how we do the division of a complex number. Let's practice one more division question before we proceed to the past year question. So for this example, notice that the bottom part is a complex number and you are asked to express your answer in a plus bi form. So the bottom part must be changed into a real number by multiplying with its conjugate. Conjugate of 5 plus I is 5 minus I. So the upper part we shall multiply with the same thing. So for the upper part here, multiply as usual. So 3 times 5, 15. 3 times negative I is negative 3i. Negative 2i times 5, negative 10i. Negative 2i times negative I, we shall get positive 2i squared. And for the bottom part is a squared minus b squared. So it's 5 squared minus I squared. So for the upper part, let's simplify. I squared becomes negative 1. So group the real parts together. So it's 15 minus 2, which is the 13. So as for the imaginary part, it should be negative 3i minus 10i. So it's negative 13i. As for the bottom part, notice that the I squared is negative 1. Therefore, 5 squared, which is a 25, plus 1, we should get 26. Now we can split it into a plus bi form, which is 13 over 26 minus 13 over 26i. So you can further simplify it into half minus half I. That's how we solve for the division of a complex number. Let's look at how the past year questions ask about the division of a complex number. Have a look here. Throughout this question, the use of the calculator is not permitted. That means you cannot key in this into your calculator and get the answer straight away. So now you are given that u is defined by this, 4i over 1 minus square root 3i. For the part 1, express the u in the x plus iy form, where the x and y are real and exact. So we'll only discuss for part 1. So for part 1, notice that the bottom part here is a complex number and you're asked to express in this form, the standard form. So what we need to do now is to multiply the conjugate of the bottom part. So 4i over 1 minus square root 3i, we have to multiply with 1 plus square root 3i. the conjugate of 1 minus square root 3i. So for the upper part, just expand as usual. You should get 4i plus 4 square root 3i squared. As for the bottom part, we should have a squared minus b squared, which is 1 square minus square root 3i squared. So for the upper part, change the I squared into negative 1. We should have negative 4 square root 3 as the real part and 4i as the imaginary part. As for the bottom, 1 squared is 1. Square root 3, when you square it, it becomes a 3. And for the I square, it becomes negative 1. And therefore, the bottom part, it becomes 1 plus 3, which is a 4. So now we can actually express our answer in the x plus iy form, which is negative square root 3 plus I. This is how we express our answer in the exact form. And you can get the 3 marks easily. Let's have a look at the more complicated question now. Throughout this question, the use of the calculator is not permitted. So now you have 2 equations here. And given that z and w are both complex numbers, so you are asked to solve the equations for the z and w, giving your answers in this form, the standard form, where the x and y are both real numbers. So to solve for this kind of questions, where you need to solve these 2 equations simultaneously to get the z and w, the first step is to rearrange the first equation into, for example, for this question, I'll rearrange z in terms of w. So it becomes I minus 1 plus I times w. And we can actually expand this to get I minus w minus iw. Then we can substitute this z into the second equation, which is 1 minus I times I minus w minus iw plus iw equals to 1. So now we can expand it one by one. So first we'll get I minus w minus iw, then minus I square plus iw plus I squared w and plus iw equals to 1. So for now, let's simplify it. The I squared, we can change it into negative 1. And this negative iw and this positive iw can be cancelled off. Therefore, it's left with I minus w plus 1 plus iw minus w equals to 1. So this 1 and this 1 can be cancelled off, and therefore we will have iw minus 2w equals to negative I. We should group the w terms together so that we can factorize the w, and hence the w will be equals to I over 2 minus I. So this is our w's answer. But the problem is, you are asked to leave your answer in this form, the standard form. But what we are having now is a fraction, where the bottom part is a complex number. So whenever the bottom part is a complex number, then we have to do the division of a complex number by multiplying with the conjugate of the bottom part, which is 2 plus I. So the upper part also have to multiply with 2 plus I. And hence, we will have 2i plus I squared at the upper part. The bottom part is 2 squared minus I squared. So to simplify it, it becomes negative 1 plus 2i over bottom part I squared is negative 1. So it's 4 plus 1, which is a 5. And now we can split it into the real part and the imaginary part, which is -1/5 plus 2/5i, and leave the answer in x plus iy form. That's the w. And don't forget the z. You are supposed to substitute this answer into the first equation here, and hence the z should be equals to I minus w is -1/5 plus 2/5i minus I, w again, -1/5 plus 2/5i, which is equals to, let me open up the bracket, plus 1/5i minus 2/5i square. So you just need to plus all the real parts together. So this one, the I square is a -1, and hence here becomes a positive. So the real part is 1/5 plus 1/5 plus the 2/5. Then we'll get 3/5. And for the imaginary part is 1i minus 2/5i and plus 1/5i, which gives us 4/5i. That's how we solve for this kind of question, the question that involve two equations. Alright, so that's all for the lesson today. Thank you.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.